So we made a ton of improvements to the design, and this is the final version. We've ordered the boards, we've ordered the parts, so we're going to be able to start production next week. Um, so, kind of a comparison, it's considerably more sensitive than before. Um, so if we look at one of the things that we detected before, now we can detect the Fiesta-ware bull from several feet away. And it's considerably more sensitive. So I've changed the arrangements of the diodes, improved the parts. It's much easier to put together now, and this is the final version for the basic. We've also decided to make the design modular so that the advanced can actually plug into it. So that way folks that just bought the basic can upgrade to the advanced just by buying the advanced module. And we're gonna have that done soon. We still got to get the Bluetooth so that I can talk to the iPhone 5 because it uses a new Bluetooth method, and we're gonna have that probably solved sometime next week. But it works with Android currently and the older iPhones. So a lot of great progress. So now it can actually detect americium-241, which are the little buttons from smoke detectors. And what's really amazing is this is an alpha emitter, but every once in a while it produces a couple gammas that are very low energy, and it can detect them. So this is a really common source that's very, very nice. The other huge improvement is I had mentioned that the APOC can do basic energy leveling for the gammas. Not enough to get nice clean lines for gamma spectroscopy, but enough that with a bit of math, you can figure out what isotope released the radiation. So what I did was, using the advanced, the setup, I have made an isotope identifier. And it can currently identify 5 different isotopes. For instance, so we got cadmium 109 on there. So we got cadmium 109, and it's successfully identifying them. Alright, so we're going to have it identify our next source. Next one's going to be americium-241. Americium-241. Next, we're going to have it identify barium-133. And we're going to do manganese-54. So now we're going to check for cobalt-60. Bam. So it can identify, so it can identify 5 different isotopes right now: americium-241, cadmium-109, barium-133, manganese-54, and cobalt-60. Why this is an exciting development is now it's a handheld device that can figure out individual elements and isotopes without physical contact. Basically, it's like a tricorder from Star Trek, at least one step towards it. So I can't necessarily do spectroscopy. What I found was that it can do approximate energy levels, and each isotope produces a kind of a fingerprint, and that's what we're reading, is that unique signature. So definitely, this device is now very different from a Geiger counter. Geiger counter can't do this kind of thing, so it's a profound step.